हेलो डियर स्टूडेंट्स, आज हमारा टॉपिक है मैग्नेटिक फोर्स इन अ करंट फ्लोइंग वायर. This topic is given in your chapter 4, and in continue of the previous video, uh, the topic taken from that chapter, magnetic force in current flowing wire. How the magnetic force produced by a current flowing wire. See, here I taken this one is a magnetic field, and magnetic field is noted by B. What is the source of magnetic field? This may be the wire magnet, or this may be any current flowing solenoid, or it may be any one. But the magnetic field is uniform. What thing we are looking here? Magnetic field is uniform. Why? How you guessed it that magnetic field is uniform? The magnetic field is uniform. This is because all the magnetic field lines, these are the magnetic field lines. These magnetic field lines are parallel to each other. If magnetic field lines are parallel to each other, means magnetic field B is uniform. If the magnetic field lines are not parallel to each other, then magnetic field is non-uniform. Here magnetic field is uniform. It's okay. And in this magnetic field, a current flowing wire PQ, see this one PQ is the current flowing wire. This PQ is a current flowing wire. This PQ is the current flowing wire in which I current is flowing, and in this wire, uh, the length of wire is L. Let's suppose the length of wire PQ, this is the length of wire. Let's suppose the length of wire is L, small l. The length of wire is L. From P to Q, the length of wire is L. Again, this is kept like way that means this is a magnetic field, and your this is a wire, but may be any angle. This is not exactly perpendicular, this may be any one direction. So let the angle between current flowing wire and magnetic field is theta. So what is here theta? Theta is the angle between theta is the angle between PQ and B. PQ and B. PQ means current flowing wire and B means magnetic field. Here theta, generally theta taken perpendicular, but here I taken theta some general value. Okay. So what it says that if such situation created, means a current flowing wire kept in uniform magnetic field, then a force acts over the wire. This force is called magnetic force. And such examples you had seen at the home appliances like doorbell. Doorbell is one of the example of the magnetic force. When current make on or switch is on, then what happens? The current flows, and in that time the hammer stuck with the well, and the sound comes because there is a magnetic force produced, and that shows that back. Or another cases, see another example, doorbell is one example where magnetic force produced. And think about other examples in your home appliances, maybe your mixer, maybe the juicer. In such machine, when the current given to them, they start rotation. There is a force acts in that machine. This is the magnetic force example, and so many other cranes, so many things are other also. But simple example, doorbell and your mixer, these are based on magnetic force. So when current is given to them in the magnetic field, a force is produced. See here this force is produced. This force is perpendicular to the both. Later I will explain the direction, but now first you see, and on what factor the force F depends. First you see this thing. The force depends on the magnetic field. See, very clear. As you increase the magnetic field, force also increases. As you increase the length of wire, the force also increases. As you increase the length of wire or current, that force is also increased. Means three factors. First you see, force depends on magnetic field, force depends on current, force depends on length. All these are here. This is the magnetic field, this is the current, and this is the length of wire. PQ is the length of wire. So, and one more thing here, force depends on the sine theta. Now see very clear. Theta, what is theta here? Theta is the angle between current flowing wire and magnetic field. This force also depends on theta. So F is directly proportional to theta. So if you will combine all these, what you will get? F is directly proportional to BIL, B-I-L sine theta. You combine all, then you will get F equal to BIL sine theta, or you remove the proportionality constant, this one, let this is K, so BIL sine theta. It's okay. Now you take K equal to 1, so F equal to BIL sine theta. So this is the magnetic force. This is the formula for the magnetic force. F equal to BIL sine theta. And now see, this is the mathematical formula, but you have to analyze it. This is called the physical significance. What is the physical significance of this formula, or what is the interpretation you can say from this formula? We will see. Now, first of all, it is very important that theta is here major factor. See, theta is here major factor. If, let case 1, if theta is 0, what it says? Tell me. If theta is 0, what it says? Means the wire PQ comes along the magnetic field B. See this situation. This is the magnetic field B, and wire PQ also comes in this direction. See, means there is theta 0. If theta is 0, then F equal to BIL sine 0. Sine 0 means 0, means there will be no force. F equal to 0 means no force. If there is such situation comes that the wire PQ itself along the magnetic field, there will be no force. Force will be 0. It's okay. This concept is clear. Means the force decided by the direction of the wire with the magnetic field. If it is along the magnetic field, force is 0. Now see some other cases. Now some other case. Case 2. If theta is 90 degree, tell me, explain. What is the 90 degree means? 90 degree means the magnetic field is acting this direction, okay, and wire PQ exactly perpendicular, means PQ is here. Then what happens here? Theta is 90. In this case, you tell me the force F equal to BIL sine 90. What is the value of sine 90? This sine 90 is 1. So F equal to BIL. This is the maximum force. Why? Because sine 90 becomes 1. So here force is not 0, but this force is maximum. You will see. Why this force will be maximum? The student who taken the mathematics know easily. The value of sine 90 is maximum, that is 1. And value for other angles in case of sine, that will be less than 1. So here force is maximum in this case when theta is 90, means wire is perpendicular to the magnetic field. Here no force. See, if we can also see that if theta is 180 degree, what is meaning of theta is 180 degree? Or here we can write theta 180 degree. Theta 180 degree means what? That wire PQ is written like that. See, here is Q and here is P. This situation comes. Means PQ, that is reversed. In this case theta 180. Sin 180 will be again 0. Again force 0. Means we got the conclusion that magnetic force will be maximum when the current flowing wire is perpendicular to the magnetic field. This is the basic concept. And now I want to show the directions. I want to show the directions. Means how the direction of magnetic force determine. See, direction of magnetic force. For this, first rule given by the Fleming's left hand rule. See what Fleming given, just I will explain. Fleming's left hand rule. Fleming given one rule, and where he tried to explain the well known famous rule, and according to that first you see here that if this is a thumb, this is a forefinger, and this is a middle finger, what is told that F B I. Now try to understand what is B here? Magnetic field. What is here F? Magnetic force. What is here I? Current. Now see, I am trying to explain to you. See, this one is the left hand, and what Fleming say that you stretch your thumb, forefinger and middle finger like that, perpendicular in this position. Means all these must be perpendicular, and if the magnetic field acting along this finger, current flowing along this finger, see both are perpendicular to each other, magnetic field and current both are perpendicular to each other, then magnetic force acts perpendicular to these two. Now see carefully, if current flowing along the middle finger, magnetic field flowing along the forefinger, then the magnetic force will be along the thumb. This may be like that, may be like that, or may be like that. This may be any one shape, but all must be perpendicular. This is one example. All must be the perpendicular. So you can guess the direction of magnetic force. Now see, this one basic concept I want to explain you. This diagram is made in the board, and board is two-dimensional plane, means xy is only there, means only two axes in the board can be represented. But what Fleming given or what I want to explain you, that is in the three dimension. Three dimension means let x axis, y axis, then z axis. For example, in the corner of the room, let this is x axis, this is y axis, this is z axis, like that. So all these are perpendicular to each other. This thing told by the Fleming. This is a Fleming given two rules. Once again I want to remind you, Fleming given first rule is Fleming left hand rule. Left hand rule, that is only for the force. देखिए, left hand rule given for the force. So you can remember the left hand rule for force, and what it says, FBI. You can remember in short, FBI. FBI. You can remember it, FBI. And Fleming given another rule which will come later in your chapter 6, that is called Fleming right hand rule. That is for the induced current. That is you will see in the chapter 6. Then I will discuss. Now Fleming left hand rule. You also some introduction given in class 10 also about the this one. Okay. Again, now another type of the magnetic force. See, now certain change in that topic, that magnetic force in a magnetic force. See, new topic I am writing here, magnetic force due to moving charge particle. Moving charge particle. Yes. See what it says, that when current flowing wire kept in magnetic field, a magnetic force acts. Similarly, when a charge is moving in the magnetic field, then also a force acts. This invented by the Lorentz. Lorentz is name of scientist. Lorentz. The Lorentz invented this force, that a charge moving in magnetic field also experiences a force. See what he told, that this is a magnetic field. See, this is the representation of magnetic field. Which type of magnetic field you can say in the previously I discussed? This is a magnetic field. Which type of magnetic field? See, this is the magnetic field which acting perpendicular to the upward to the plane of board. This one, that is dot, and cross will be downward, upward this one. So this is the magnetic field. This is the magnetic field. Okay. In this magnetic field, a charge Q. See, this is a charge particle Q. This moving with speed V. Then what will be the force produced in the charge? With the Lorentz force, Lorentz told that when a charge particle Q enters in the magnetic field, in this magnetic field, if charge particle moving with speed V, and if the angle between magnetic field and charge is theta, then what is the Lorentz force? Again, he given the concept that the force produced will be directly proportional to Q. Q means charge magnitude. Force directly proportional to B. B means magnetic field. Force directly proportional to V sin theta. See, very clear. Here V is there, speed of the charge particle. Sin theta means angle between magnetic field and charge particle. Combining both, F is directly proportional to BQV sin theta, and you remove proportionality constant VQV sin theta. If K is equal to 1, F equal to BQV sin theta. This is the Lorentz force. This is the Lorentz force. Now see, this Lorentz force says again, that if theta is 0 or 180, sin 0, 1, 0, sin 180, 0, then force will be 0. If theta is 90 degree, means the charge particle enters perpendicularly, then sin 90 is 1, and the maximum force is BQV. This is the maximum force. Again the concept clear. The force may be the minimum here if Q is 0. यदि चार्ज 0 है, if V is 0, माने चार्ज रेस्ट में है, then also the force is 0. Now see here these two basic concepts I want to explain here. What it says, if Q is 0, means proton is positive, electron is negative, but same magnitude, means proton and electron having the charge particle, their magnitude. But if neutron entered in the magnetic field, what you will say? Neutron having no charge, means neutron will not experience any type of magnetic force when it enters into the magnetic field. If V is 0, magnetic force is 0. What it says? Means if the charge enters in the magnetic field but it becomes stationary, it does not move, what happens? Speed becomes 0, and when speed becomes 0, the magnetic force becomes 0. So this concept is used in so many electric devices, cyclotrons, electron microscopes, or oscilloscope, and in so many electrical devices this concept is used. If charge is moving inside the magnetic field, a magnetic force produced, and this magnetic force produced called Lorentz force. Okay, see, in this video I discussed magnetic force due to the current flowing wire, F equal to BIL sin theta, and second, magnetic force due to the moving charge particle, F equal to BQV sin theta, and I discussed how the magnetic force depends on the factors. What is the direction of magnetic force? Direction of magnetic force determined by the Fleming left hand rule, that force will be perpendicular to the both, and in this case also the same, F B Q in the place of I, here will be Q, so this can be used. Now I will say to you that some questions are given in NCERT book in the exercise, that in your exercise in your exercise NCERT, there are question number 4.4, 4.5, 4.6. These you can solve now. You are able now to solve. If you understand these things, now you are able to solve. So you solve these, and you also solve the examples 4.3, 4.4, 4.5. You also solve the examples in the NCERT. You will get the enough confidence in this concept. So this is my advice, that you, in parallel you prepare, in parallel you read in the book, you make a note and make understanding, and if any doubt you tell me in my group, you tell your doubts, I will answer immediately. So this is enough for today, and we will see tomorrow. The next topic will be the forces for two parallel current flowing wire. Means now today I got the magnetic force in one wire, and next video I will see what is the magnetic force if the current is flowing in two wires. See, these are the two wires. Now today got the current flowing in one wire exerts a magnetic force, or a charge moving in the magnetic field exerts a magnetic force. Now tomorrow or next video we will see this one. Means two wires are there and current is flowing, then how they attract, how they repels. This concept we will see tomorrow. So this is suggestion that you attend all the video and you make understanding with the video and with the help of books. In the parallel study is needed to you. Thank you. Have a nice day.